image here that you worked on for just a brief exercise for homework. And we were talking about how maybe this was had to do with inequalities. Inequalities we saw before were a way of shading lots of points. Okay, so what else besides inequalities? What about these boundaries?
I interpreted it as like equations of two different
Okay,
lines.
right. Yeah, so it looks pretty straight. So line. So then, did you write the equation of either line, Sarah?
Yeah, for I I don't remember which one's which, but for the first, for one of the lines, I got 1/2 x minus 2, so that's the bottom line.
Okay, so all right. Anybody else write the equation for the top line? Can we do it on the fly here? So y-intercept of 1. And then looks like, what?
1.5.
Negative 2/3.
Negative 2/3. So it's a run of, yeah, so it's a rise of 1 to a run of 1.5. Does that do it? So at 1.5, 3/2, we get negative 1, and then that's 0. Yep. So, okay, making progress. So we've got the equation of these boundaries. And so now how can we write one? So what defines these points where these would not, points out here would not, so what defines these points relative to these lines? Anybody figure this out?
I got that for the top one, it's going to be less than that equation.
Okay.
And then for the bottom one, it's going to be greater than.
Yeah, so greater, like, so you're thinking above and below, right?
Yeah.
Yeah, so below, right? So if we're thinking above and below, then we're thinking y coordinate, right? So we want all y values that are we want all y values that are above what?
Oh, 1/2 x minus 2.
Yeah, okay. And then?
And negative 2/3 x plus 1.
Yeah, so sorry. All right, so I do have this wrong? Yeah, we want everything above that, right? We want above that and below this other one. And that will be these points, right? So that will be all these points that are both above that line and below this one. Okay, so this is a technique for if you want to create a solid region and you want the boundaries to be above, some kind of above and below boundaries, you're going to use a y inequality, right? And so then if you wanted some kind of region that was bounded on the left and the right, I'll let you fill in the blanks, right? If you want something bounded kind of with a left boundary and a right boundary, I think you can make the step to do that. But then as something new here, any questions about this exercise? Okay, so then as something new, what about this? So I suppose that we could, you could use the same technique of above and below. Like we could figure out what the y equals the bottom half of the circle and y equals the top half of the circle, right? And then do the exact same thing we did in the last problem. But is there another way? Is there something that doesn't really depend on above and below or left and right? Is there another thing that might be more kind of efficient? Because the above and below that require square roots, kind of maybe circles. aren't, they're not like nice and clean with respect to the x and y axis, right? It requires squares and square roots, which is fine, we could do it. But is there something maybe slicker, something more efficient to get this region?
I have like two thoughts in my head.
Sure.
First is polar coordinates, and the second is like x squared plus y squared is less than or equal to some radius squared.
Okay.
Some deviation of that.
All right.
equation.
So with polar coordinates, what's kind of what in terms of polar coordinates? What might be a big obstacle to doing polar coordinates for this particular?
For me, I didn't know how to change the pole so that it wasn't.
Yeah. So polar coordinates are based on distance from the pole and angle around this way. So you'd have to do a transformation, and that transformation might be kind of get a little too complex, right?
Yeah.
So what was your other idea?
Use the circle equation x squared plus y squared.
So let's just write, okay, so x squared.
Yeah.
Can we write the equation of the circle? What is the equation of the circle? So this is 4, 3.
The general equation or the specific?
Yeah, this specific, so this circle, and a circle is just the edge, right? It's just the perimeter. It's not everything filled in. So the circle would just be the points around that edge. So could we write that circle? Do you guys remember?
Anyone else want to take a stab?
So yeah,
before I go
so he said x squared plus y squared equals something. Will that get us the equation of this circle?
It would not.
How do we need to kind of change that?
So it's the quantity x minus 4 squared plus the quantity y minus 3 squared.
Okay, there we go. So we got the center, 4, 3, good.
Is equal to, is that radius of 2? 2 squared.
Yep. Looks like I got the radius is 2 there, 4 to 2, 4 to 6, yep. Okay, so 2 squared. And so what do we say? We say this is defining all points that are a distance of 2 away, right? So x, y. This left side, you can think about all x, y points such that we are a radius of 2 away from 3, 4. So that's all these points. Okay, so if I were to put that into GC, I'd just get the circle, which is just the rim, right? It's just the perimeter. But I want to fill it in. Somebody new, what can I do?
Did you make an inequality that's less than or equal to 2 squared?
So what would that mean? That would mean like all points, what? Whose radius is?
Less than 2.
Less than 2 or equal to 2. Is that what we want? Yeah, so by doing less than or equal to, you're like considering like every radius, like from 0 up to 2. And when you do that, then you get all the points in there. Yeah. So here's something like this, kind of alternate to this like bottom and top boundary, left and right boundary. You got like, it's like using a circle. It's like all points that are less than or equal to a radius of 2 away. And that shades in the circle. Okay, so that will get you thinking about that next kind of harder assignment about regions, right? So our goal is like to have lots of tools and to be able to create like sophisticated animations that back up what we want to teach. So we want to like build our tool chest of things we know how to do, and part of that will be making filled-in regions, right? To demonstrate, show whatever it is we want as part of an animation. Okay, any questions? Okay, so let's change gears to the constant speed homework. And so I'm just curious. There's no right or wrong answers, but I'm just curious. How long did the constant speed homework take you to finish? And if it was 5 minutes, that's perfectly fine. If it was 30 minutes, that's perfectly fine. If it was an hour, I'm just curious. So how long did you spend completing the constant speed homework, would you say?
It took a while.
It took a while. Okay.
Yeah, and I also spent like probably more than an hour because I forgot that you only wanted us to do the first like 4. So I was almost done with the whole thing.
Oh,
and I
yes.
was taking
Well,
way
yeah, if
too
you did the whole
long.
sheet, it's going to take a while. But so for those of you who just worked on the part that I specified, how long did that take?
About like 45 minutes to an hour, I think.
45 minutes to an hour? Just
I think it took me like 30 minutes.
30 minutes? Okay. All right. I just want to get a feel. Okay. So let me ask you this. Did you draw a picture? Did anyone draw a picture to do this?
For the last one, I did, just to kind of get the whole, like, the distance between Phoenix and Los Angeles thing.
Okay. All right. Okay, so in terms of like talking about calculational versus conceptual learning and teaching, so a picture is always going to be helpful. And so I've made an animation. And that's going too slow. Is there something else running here? Let's close this. Sometimes the slider just runs so slow. Let's try that. And then jerky. Don't like that. But that's what we got to work with. Okay, so I made this picture here. And so I've defined some variables here. And see if is that what the assignment specified, or is that what you came up with? I said X is the time since leaving Phoenix in hours, and Y was the distance from the car to LA in miles. Is that consistent with what you did in the assignment? Okay, so having those as our variables, I want you to, when you draw a sketch of this, that's our surfboard, by the way. We're all piled in there. We got our surfboards. We're gonna go surfing. Okay, so when you do this, you're not gonna have the animation, right? So you can, all you can do is draw something like this. So you're drawing like one static moment, but as you're thinking about the problem and understanding it, we're thinking about it this way, right? We're thinking about it this way. So in your picture, it might look something like this. I want you to embellish the picture. I mean, add more stuff to it. So add more stuff to this picture. So yours will be static, mine's dynamic. That relate to y. All right, so we got this variable y. So, and notice that I'm starting at t equals 3 hours here in my slider. So I'm starting at t equals 3 hours, and then I'm just letting x increase in time. So time is increasing, and then we see the car moving. So how could you add to this picture to describe variables related to y? Variables related to y. So take a minute, see what you come up with, right? So you are labeling quantities related to y and adding that as in the picture. That's good. That was the point. Talk. So what was one thing you came up with? Quantities related to y in this image. Ashley, what was one thing you came up with?
As like the car goes closer to LA, displaying the change in y, the dy behind the car as it grows.
Cool. So I'll pause it. So something like this.
Yeah.
Is that what you're thinking? And you said that's what quantity?
Dy.
Okay, nice. All right. Another group. Who was in another group?
Like the change in time.
Okay, so how does it do that?
Or X.
So can we illustrate the change in x on this image? Yeah, so that's why I was trying to bring your attention to quantities related to y, right? So quantities related to y. You can't really, with time, you can't really show things related to x. We know it's there in the background, but in terms of the picture, it's hard to illustrate x-related quantities. So what other y-related quantities did you guys come up with?
Me and Elizabeth said that we can like represent like the initial distance, like y initial by the whole thing from Phoenix to Los Angeles.
Initial?
Yeah.
This?
Yeah.
Okay, what would be, so in terms of the way I have the animation set up, what would be another way to, yeah, and especially like, so like given this, yeah, so that's valid. Given that this is dy, is this, so Ashley, is this accurate, or did you want dy to be all the way back to Phoenix?
I was thinking like from Phoenix because it's your full change, but I don't know if you're starting at 3. I guess your dy is that.
Right. Yeah. So okay. Yeah. And so dy starting from Phoenix, that'd be valid. In terms of my animation, like I said, so I didn't quite get it. I'll move over here. Whoa. Yeah, I do not have control here. Stop. Okay, perfect. All right, so in terms of the animation, I have the animation starting and repeating from here. So then what would be another, related to this dy, what would be another y initial? What would be y initial related to this dy? So Yasra, did you say this?
Yeah, I did.
How would you change this if this is dy?
Like the end segment would be the y initial then.
So you want me to change this or change this?
No, the end segment for the dy.
The end segment. I'm not sure what you mean.
The end segment, do you mean like the right post segment?
Yeah.
So you want to move this? Is that what you're saying?
Let's see, like kind of where the car is right now.
Yeah.
Yeah.
So what about that? So
that would be like the y initial.
So just that right there is y initial?
Yeah. Or actually maybe the other side, because we're counting that way, right?
So y initial is going to be a distance, right? It's going to be a span.
Y initial is the distance from that point from Phoenix.
So
it's that initial distance.
This is y initial. Is that what you're saying?
Yeah.
Agree with that? So what was y again? Y values are?
The distance from the car to LA.
Right, the distance from the car to LA. So is this y initial? Ashley says no.
Y initial should just be a point.
Y initial is a point. Y initial is that. Angel, what do you think? Is y initial a point, or is it this distance here?
I think it's the distance from like where you have the leftmost end on this segment.
Yeah, this?
That all the way down to LA.
All the way down to LA, so now we have another option. This is y initial. So is it a point? Is it this distance? Or is it this distance? It is one of those three things.
I'd say it's the distance on the left.
Okay.
Yeah, same.
People are starting to agree with Angel?
Mm-hmm.
Yeah, so if it's a y, if it's y initial, it has to be a distance from the car to LA, always. So whether it's y initial, y final, or our variable y, it's always going to be a distance from the car to LA. So yeah, so that was right. there's our y initial. Okay, and then anything else? So we've kind of overlooked the obvious choice here, the obvious thing to talk about. What else can we label here? Anybody?
Like y final?
Okay, y final. But really, it's kind of...
Couldn't we just label, like, since it's the distance from the car to LA in miles, couldn't just that entire distance be labeled as y, I think?
Entire distance from where to where?
From, wouldn't it be from the car to LA? Or from,
Yeah, what is y? What is y? Y is?
To LA?
Yeah.
Okay.
So it's like, if we've gone a little bit from our initial and now we're pausing, what is y? Or what's
where we're pausing at to LA?
The current value, right?
Yeah.
Everyone agree that would be like y? It's kind of like y final, but it's changing, right? It's variables vary, right? Variables vary. So, do we agree with this? Are we good? So I have this. Yeah. And if you don't understand or don't agree, this is about discussion. So speak up. But this is kind of what I'm hearing that we're coming to here. This is really bad. So one more time. What is the black? Can you guys see the colors blue, black, and pink? Can you see that? What's the black distance?
The black would be y.
Okay, she wants y. Someone else, what's the pink distance?
That'll be dy.
dy. And then the blue distance?
Y initial.
Good. Okay, so I've got that like that. All right, so here we go. So let's make a relationship of those three. So when you see this y is there to there, dy is from there to there, and then y initial, what basic distance relationship can we write with those three?
Y plus dy equals y initial.
Is that, you guys agree with that, looking at that picture? And then, let's solve for dy. So dy would be y initial
Minus y.
minus y. And y is our, it's our changing, it's our variable, but it also kind of takes on the role of y final, right, at any given moment. Would you agree? So what do you think of this? What happened? So I got dy equals y initial minus y final. Yes? What do you think? What's going on here? What's going on here? Do you recognize this or something like this?
Recognize y final minus y initial.
Oh, and what's y final? What's that, Richard? Y final minus y initial. What's that?
The change in the distance from
Right.
LA to.
So that's just our generic. So if you had a y final minus y initial, that'd be like change in y, right? So what about this? Is this right?
For this case, yeah.
Why? How could y initial minus y final be dy?
Because in context of the problem, we start off with the initial distance.
Okay.
So, and that's covering like the entire distance from the car to LA, which is going to be a larger distance than what y final is in this case, which is like the distance left between the car and LA.
Okay. Other thoughts about this? What's going on here?
I think it also might be because we're counting like towards LA instead of Phoenix, so it works out.
Okay, so something's up here because the amount of variation in a variable should be y final minus y initial. We got y initial minus y final. So something's wrong. We haven't really gotten to the heart of what's going on here. What's wrong?
Is it because, wait, so like you're saying this is wrong?
Well,
is that what you're saying?
This is, we know this is true, right?
Yeah.
We took our diagram, which is good. It's a good diagram. And we concluded from our picture this. It's not good, right? Something's wrong because the change in a quantity has to be the final value minus the initial value. So something in our thinking, something is going on here that's causing this conflict. We need to understand the situation so there is no conflict, right? We need to understand the situation so that we arrive at actually this. This is what the change in a quantity is.
I think it has something to do with the fact that the change in y is like it's negative because we're not, because the speed that we were given for the problem has to do with him leaving Phoenix, like how far he is from Phoenix, not how close he's getting to LA.
Okay.
So if we had like dy equals, so if you viewed dy as being negative, then you could factor out the negative from yf minus y initial, and you'd get, or y initial minus y final, and you get dy equals negative y final minus y initial.
So you're saying if you wrote it this way, this would be less than 0? Is that what you're saying? Because this is less than this. Is that what you're saying?
I think so.
What do the rest of you think?
I thought John was saying it'd be like y final over y initial would be less than 0. That's how I interpreted it.
Were you talking about the ratio, Donna?
I think so.
Okay, it's hard to explain these things.
What is happening with y? What's going on with y?
Y is decreasing as time passes.
Y is decreasing.
Mm-hmm. So change in y should be negative, right?
What about the rest of you? If y is decreasing, change in y should be negative. Yes?
I concur.
We got 2 votes for that. What did we assume when we wrote this?
We assumed dy was positive.
Does this equation assume dy is positive? This plus this equals that? Doesn't that assume that dy is a positive value?
Because y will always be a positive value.
Right. Y is definitely positive. Y initial is definitely positive. So by doing y plus dy equals y initial, we assumed dy was positive, and by assuming dy was positive, what happened? We got something that wasn't right, right? Because we made a wrong assumption, right? We made a wrong assumption, so our conclusion then is not right. So this is actually, that length is positive, but our dy's are truly the opposite of that length, right? Because just do a quick example. So let's say right now, what was it? So let's just say y is 150. Well, in a little bit of time, what will y be? Less or more than 150? If a little more time goes by. Less. So what was the change in y?
Negative 25.
Negative 25, right? So as x increases, y is going down. So this dy is getting more and more negative. It's getting more and more negative. And then everything works, right? So then what would we say? We would say that y initial what plus dy would give us y final, right? And that's gels what we've said before. Starting value plus dy, what's that going to do? It's going to take away that much distance, right? Because dy is negative. So add dy, add the change, and you get the final value. And so then dy is y final minus y initial. So when we realize that dy is a negative and getting more negative, all is right in the universe again, right? So this was based on this wrong assumption that dy is positive. Okay, does it make sense? So this is, yes, dy is negative because y is decreasing, and so then this still holds. Dy is y final minus y initial will give us a negative value because y final is less than y initial. Does it make sense? Okay, so now we want to talk about what's going on here. Drawings. Okay, so I want to show you x and y. As x increases and y decreases. Can you guys see those numbers changing? So these are all correspondence. So we have an ongoing correspondence between x and y. As time increases, our distance from LA decreases. So looking at those values, my question is does y change at a constant rate with respect to x? Does the distance from LA change with a constant rate with respect to time since we left Phoenix by observing those values? And that's truly a question.
Are you asking us to figure that out?
No, it's just a yes or no. Looking at the numbers of x and y varying together, right? Varying together, time since we've left Phoenix, distance from LA. By looking at those numbers varying together, does y change at a constant rate with respect to x?
No.
Okay, I have one vote for no. Why not? So what are you using as evidence for that?
like specific evidence. It's more just like if you're driving on the like you're not gonna drive at a constant speed the whole time.
Okay.
There's an average constant speed, but
Okay.
you're not gonna drive 75 the entire time.
Okay, so that's an excellent point. If we were thinking about the real scenario, that would be really kind of impossible to make it the whole way at a constant speed. Okay, but so this animation or this model is based on the problem you did for homework. So this is proceeding according to the assumptions in the homework. So according to that.
So then, yeah, I would say yes.
Ashley says yes. So why?
Because they gave like a specific rate at which they would be traveling the entire time.
Okay.
At least in the model.
Okay. So what about the fact that what is X doing? Is X increasing or decreasing?
Increasing.
And what is Y doing?
Decreasing.
Okay. What about that? Does that have any bearing on this question? Is Y changing at a constant rate with respect to X? Elizabeth?
I would say kind of, because like your constant speed is like positive, and so that's times like the change in time, which is also positive.
Okay.
So like I think that's important, but I don't know
Okay.
how exactly, because like it looks like they're changing together though. Like it looks like the more time you travel, the less like distance to LA you have.
Absolutely.
Based on your constant rate of speed.
Okay.
I'll argue.
You'll argue what, Richard?
I'll argue that Y is not changing at a constant rate with respect to X.
Okay. What's your argument?
So typically with the constant rate, like the ratio between Y and X is like a proportionality constant.
Okay.
And I'm just like looking like, at first at the beginning it's like, let's say 230 divided by 4, it's going to be a bigger number, but then when Y is around 60, X is not that same proportionality constant, it's increasing.
Okay, good. So yeah, if Y is going down while X is going up, there's no way this could hold constant.
Yeah.
There's no way, right? Okay, very good. All right, so let's I'm going to show you some more. So now I'm going to keep showing you X and Y, but I'm going to show you dx and dy too. So these are both going to start at 0 when the animation starts at n equals 3. And then we're going to get from x equals 3, we're going to get the change in X and the change in Y. And like we said, the change in Y are negative. Can you see the negative sign there? There's a negative sign there. So just let me show you that. When X equals 3, we're 280 miles from LA. Change in X is 0, change in Y is 0. And then when I hit go, what happens? Changes in X, change in time is increasing, change in distance is decreasing. We're getting Y, yeah. Because Y is decreasing, dy is getting more negative. So anyone want to change now I'm showing you dx and dy. Any thoughts about the same question? Is Y changing at a constant rate with respect to X? Okay, let me, so maybe that didn't change your mind at all? or you don't have new thoughts, that's okay. So how about, I'm going to show you now, there's y over x, and we said that that is changing. That's what Richard brought up. And then I'm going to show you dy over dx. So this is truly dividing the current value of dy by the current value of dx at every moment. Okay, this is doing an actual quotient, a division of the current value of dy to the current value of dx as x changes. And what do you notice?
So I'm interpreting it as like the y over x is counting for like specific points in time.
Mm-hmm.
But like a change in y over the specific time in x isn't going to be the same as a different time.
No, it is.
But,
that's what I'm telling you. As x and y change, this is truly every time x and y changes, it's doing a new. It's recomputing the quotient.
yeah, no, like so at like two different, or like the change from one point to the next is still gonna be. I lost my train of thought and how to describe this.
Sorry, I interrupted. It sounded like you were saying that this wouldn't stay constant.
No, I was talking about the first one, because the first one's just doing like 1 point in time for one distance, but the second one's doing a change from any point to any time.
Okay.
So that change is constant. But at one point, it's not constant, I think.
But if I freeze this, this is now calculating these two ratios for these four current values. And then if I go to another time, another x value, say that one, it's again computing this ratio and this ratio. So dx and dy are each changing, right? They're changing as x changes. And then this is computing that ratio for every time x. So maybe that's not what you were saying. But I just want to make sure that's clear. So thoughts. So what are we saying? Are we saying yes or no? So let's just take a poll here. Is y changing at constant rate with respect to x? Yes or no? Richard, what do you think?
No.
Richard thinks no. Okay. Donna, what do you think?
Yes.
Yes. Sarah?
I'm going to say no.
No. Okay. Yasra?
I'm gonna say yes.
Yes. Angel?
No.
No. Elizabeth?
I'm gonna say no.
No. Ashley?
I think no, I don't know. I guess like the change is the same. But maybe because you started your like graph at a certain point, like not at the total thing, it's different. Like if you had a graph that was just y equals, I don't know, like 2x, and then there was the intercept was 0, then the rate is just like 2,
Okay.
you know? But if you have like an intercept of like 4,
Okay.
then the ratio between them isn't going to be the same, but the change is always the same. Is that going to make sense?
Okay. So are you arguing for it is constant rate or not constant rate of change?
Okay, I'll say yes.
Okay. Yeah, it sounded like you were arguing for constant rate of change. So y it does not equal to kx, right? But what does this say? If dy over dx is constant, then it says that dy is equal to some constant dx, right?
Yeah.
Does this say, so this is, we know this is constant rate of change, right? So is this saying that the changes are in constant rate of change, or is it saying that the values, this is the big question, is this saying that x and y are in constant rate of change, or only dx and dy in constant rate of change?
Only
Right.
dx and dy, not x and y.
Okay, so we have one vote for this does not show that x and y are in a constant rate relationship, but only dx and dy.
I would agree with that too.
Yeah.
Okay, cool. So all right, very good. So let's keep going. So I want to show you how you can open up a second graph window, and we're gonna plot the correspondence points of time since left Phoenix and distance from LA, and then that point will be changing because those variables change. So if you go to if you start a new math line and you do Control-2, if you use apostrophe, it does not mean like derivative. So this keystroke using apostrophe on x and y, it's not derivative. It's telling GC to open a second pane on the right. So let's plot the initial point, which was 3 hours and what is the initial point? 3 and what?
I think it was 280.
280. Thank you. And then let's plot, so that's initial, and then let's plot this point, which I've used parameters or variables, capital X and capital Y. So I can copy and paste that. So those are already in GC as the current values of X and Y. So I want to plot that. So here we go. Let's graph that. I'm going to need more room. And here we go. So let's try this. Can you see the red point? Okay, so now I've given you more kind of another representation of this. I'm showing a point, and this is what, so my, let's make sure we know what our quantities we're doing here. This is X, which is time since Phoenix, and this is Y, which is distance to LA. So are we sticking with our answers? So now I'm giving you a visual representation of how X and Y are changing together. Does X change, or does Y change at a constant rate with respect to X? So this is really getting to this idea of dy equals k at dx. What does that reveal? Because that's what we have. We have that changes in y are proportional to changes in x. What does that reveal about the quantities x, the relationship of x and y? In this case, the relationship of time since leaving Phoenix and distance to LA. Is anyone changing their mind? Is anyone changing their mind based on this this point now, showing correspondence of x and y at this point?
Yeah.
Who's saying yeah? Sarah?
Yeah. So I said no before, but I think I'm saying yes now because for any change in y, there's a constant change between any change in y and any change in x.
Mm-hmm. Anybody else? So is this forming a line?
Looks like yeah.
It looks like yeah, right? And could that line be written in the form y equals kx? No, right? We've already established that. How could this line be written as?
Kx plus b.
Mm-hmm. Right? So this is what Ashley was talking about earlier. She's talking about there being an intercept, right? So if it was y equals kx plus b, then as these change, what about k? Change or stay the same? Now if we have the right starting value b.
Stay the same.
Yeah, so now it's possible. With the right starting value, wherever this line hits, and for x equals 0, the y value, then this constant. So the big takeaway here is that this relationship is about the values of y and x. This is showing us that y is changing at a constant rate with respect to x. Of course it's saying that dy, that's a given. dy is changing at a constant rate with respect to dx. But what this really is about, the important conclusion, this tells us that y and x are in a constant rate of change relationship. And so just because y is decreasing while x is increasing doesn't negate that. Okay, just because y equals kx isn't always for y over k is not. Just because y over x isn't constant, that's okay. Adding a b makes it constant. It's okay, right? So for time's sake, the punchline is that what dy equals k dx tells us, it tells us that the quantities y and x are in a constant rate of change relationship, because that's exactly what this is showing. That's what linearity is about, right? Linearity, if two quantities form a linear relationship, you have constant rate of change. So we're gonna actually build this line. So this, if you were to ask a high school student in the calculational, environment, a math environment, and you said, you ask them about lines, what would they say? They'd say y equals mx plus b, right? This is a pretty limiting and shallow, pretty sterile and shallow kind of treatment of lines, but it's what most students, that's their big takeaway. Y equals mx plus b. So I'm going to show you something that's a lot richer and a lot more conceptual, and in terms of modeling this situation or any linear situation. So I'm going to pause things here, right here. So we want to come up with all points, right? So this is showing a particular point of the correspondence of x and y, and we want to know what all the points are. So that's the way we want to think of it. We want to think of all correspondence points of time since we left Phoenix and distance from LA. Okay, so the first thing we're going to do is we're going to start with this initial point here. We know for sure that at 3 hours we are 280 miles from LA after 3 hours after leaving Phoenix. Okay, and then this is going to represent every point, every other point that's a correspondence between x and y. Are we good so far? So it starts with what? So start with our independent variable. So what? We're at 3 hours, and what? Some time goes by. How much time goes by? from 3 hours to any other time, how much time goes by?
X minus 3.
Right. And that's representing what?
The change in the time.
Right. So we are just gonna start with our independent variable, right? Our independent variable. So we have some known starting time. We're gonna let some time go by, and then that amount of time that goes by is gonna be what? Final minus initial, or dx. But then what happened as that time went by? What happened? Something else happened.
The distance decreased.
The distance decreased, right? And how do we represent that?
Y minus 280.
Okay, but we want, so our goal though, our goal is to represent y. Okay, so we want to represent y.
Oh.
So in general, what is y minus 280? How do we symbolize that? How do we notate that? What is that representing, y minus 280?
dy.
dy, right? dy. What do we know about dy in this situation?
That it's a constant, right? D times dx.
Yeah,
so,
we want to use that constant rate, so tell me.
So it would be like k times x minus 3.
Good. dy equals m dx, right? We have constant rate of change. And so our dy is our m times our rate times change in x. Okay, and so what's our goal? Our goal is to write every correspondence point. So we want to write every y final. We want to write every y final. So how do we get y final?
Would it just be y initial plus dy?
Okay, you got it. So how about somebody new? So how about Elizabeth? So what will y? This every y is like our y final. So according to what we found so far, what will it be?
So you have to do dy plus like our y initial, right?
Okay.
Or like minus our y initial.
And what was our y initial?
Isn't that like the amount of distance we started with? So for this, is it 280?
280.
3.
So 280, our y final, or every y is 280.
Mm-hmm. And then plus like your dy, which is your negative 57x minus 3.
So what we just write? We just wrote all ordered pairs, all xy all correspondence points of time since Phoenix and distance to LA. So I propose that this is much better than y equals mx plus b. So what's an advantage to this over mx plus b? Just one thing. What's one thing that's
I think it like makes you pay attention to more quantities in the situation.
good? Awesome. It's based on the changing quantities. What changing quantities do you see in here?
The change in y and the change in x.
Change in x is what? What's the change in x in here?
X minus 3.
X minus 3. There's the change in x, right? And what about the change in y?
It's negative 57 times x minus 3.
Yeah, so there, look, so you
Or
see,
dx.
yep, so you see those quantities, dx and dy. Okay, what else?
Y initial.
Okay, yeah, so you see y initial. Yeah, so right, so it's built on this idea of first x changes, but as x is changing, y is also changing, and then our final y. Remember I said this, these are like the three like underlying principles of calculus, right? The change is final minus initial. That in constant rate of change, your dy is mdx, and that y final quantity is initial plus the change. So it's all there. What if our trip looked like this? So I'm going to graph that real quick. Let's graph this. So in GC, I want to graph y and use apostrophe because I'm over there equals 280 minus 57 times x apostrophe minus 3, and I want to show that just for x apostrophe greater than n. Nope, greater than. No, I wanted to show it from 3 to n. That's what I meant. Okay, so I see that I used the apostrophes to keep plotting over here in the right graph. And so there's my relationship. So what if we started, last question, what if we had started here, this distance away, and so at the beginning we were like, going through town, and we had to stop at a stoplight, and then we get on the ramp, and then finally we get on the highway, and then what happens at 3 hours? Then I turn on the cruise control. What's the advantage to this over y equals mx plus b? I'll give you a hint. It has to do with b. What is b in this situation? Isn't b like up here or something like this?
It's usually like the y-intercept.
It is the y-intercept. Yep, it's this. So in the situation that I laid out,
Be like this. It's the starting distance, like the total distance between LA and Phoenix. That would be B.
is that what it is in this situation? Because I said that this was at time equals 0, this is how far we were. And then this was kind of our trip, and then we get on the highway, and then we turn on cruise control. And now we're heading there at a constant rate. So what about this? What meaning does that have for this scenario? Anybody? So there would be some number. We could change this into the form x plus b and get some number, and that would be this y value. And what would that have to do with this scenario?
Nothing.
Right. It's like it's meaningless, right? It's like, yeah, exactly. I mean, you could kind of make something up, like if had you started here and at a constant rate the whole time, but that's not what happened. So it's not modeling the situation. But everything in here is pertinent to our situation. There was a point in time at 3 hours when we were 280 from Phoenix. And then as time goes by, our distance changes. And then we can compute our current distance away from LA. So this, I just want to argue that this is much richer, much more conceptual, much richer, and much more meaningful than just graphing lines, y equals mx plus b. So it really models the situation. You can see what's going on right there in the equation. And so we want to practice this. We don't have time. We have to stop. But my experience with all students is that building linear relationships this way, dx first to a arbitrary point, the corresponding dy because of rate of change, and then y final equals y initial plus change in y. It does not come quickly and easily. So we're going to practice. Okay, we're going to practice. And this is the way if you've not learned this before, this is what we want to learn in this course, because this is I argue a better approach to linear relationships than just y equals mx plus b, find m, find b, sketch the line.